Hello everyone. And welcome back once again to another interesting video. In today's video we'll discuss the role of Python in data analysis, covering key libraries, data manipulation, visualization, and statistical analysis. So if you are ready, let's start today's video. Python has emerged as a dominant programming language in the field of data analysis due to its versatility, readability, and a rich ecosystem of libraries and tools. This comprehensive guide explores the role of Python in data analysis, covering key libraries, data manipulation, visualization, and statistical analysis. From introductory concepts to advanced techniques, this article provides a detailed overview of Python's capabilities for handling, exploring, and deriving insights from data. The explosive growth of data in recent years has elevated the importance of effective data analysis. Python, with its simplicity and extensive libraries, has become the go-to language for data scientists and analysts. This section introduces the significance of Python in data analysis and its widespread adoption in the industry. Essential Python libraries for data analysis. Python's strength in data analysis lies in its rich ecosystem of libraries. This section highlights key libraries such as NumPy, pandas, matplotlib, seaborn, and scikit-learn. NumPy provides support for large, multidimensional arrays and matrices, while pandas offers data structures for efficient data manipulation and analysis. Matplotlib and seaborn facilitate data visualization, and scikit-learn provides tools for machine learning and statistical modeling. Data manipulation with pandas. One of the fundamental aspects of data analysis is data manipulation. Pandas, a powerful library built on top of NumPy, provides data structures like data frames and series, enabling efficient data cleaning, reshaping, and exploration. This section covers basic operations, indexing, grouping, and filtering data using pandas. Exploratory data analysis or EDA. Exploratory data analysis is the process of analyzing datasets to summarize their main characteristics, often employing statistical graphics and other data visualization methods. Python's libraries, particularly Matplotlib and seaborn, play a crucial role in creating visualizations that help identify patterns, trends, and outliers in the data. The section includes examples of various plots and charts for effective EDA. Statistical analysis with SciPy. Python's SciPy library extends its capabilities for scientific and technical computing. This section explores the statistical functions available in SciPy for hypothesis testing, probability distributions, and regression analysis. Understanding these statistical tools is essential for making informed decisions based on data. Machine learning with scikit-learn. Python's scikit-learn library is a powerful tool for machine learning tasks, including classification, regression, clustering, and dimensionality reduction. This section introduces the scikit-learn API, covers common machine learning algorithms, and provides examples of building and evaluating models. Data visualization with Matplotlib and seaborn. Effective communication of insights derived from data is a crucial aspect of data analysis. Matplotlib and seaborn offer versatile options for creating a wide range of visualizations, from simple line plots to complex heat maps. This section explores different types of visualizations and best practices for creating compelling and informative plots. Real-world applications and case studies. To reinforce the concepts covered, this section presents real-world applications and case studies where Python has been instrumental in solving complex data analysis problems. Examples may include predicting stock prices, customer segmentation, and sentiment analysis using real datasets and demonstrating how Python facilitates the entire analysis pipeline. Best practices and tips. This section provides best practices and tips for efficient and effective data analysis in Python. Topics covered include optimizing code for performance, handling missing data, and organizing code for reproducibility. Additionally, Guidance on collaboration using tools like Jupyter Notebooks is discussed. Future trends and emerging technologies. The field of data analysis is dynamic, with continuous advancements and emerging technologies. This section explores the future trends in Python for data analysis, such as the integration of deep learning frameworks like TensorFlow and PyTorch, the rise of specialized libraries for specific domains, and the growing importance of interpretability in machine learning models. Conclusion. In conclusion, Python has established itself as a powerhouse in the realm of data analysis, providing a versatile and accessible platform for professionals in the field. From data manipulation to statistical analysis and machine learning, Python's extensive libraries make it a preferred choice for extracting valuable insights from data. This guide serves as a comprehensive resource for individuals looking to harness the capabilities of Python for effective and impactful data analysis. That's all for this video. If you found this video helpful, don't forget to subscribe, give it a thumbs up, and hit that notification bell for more content, so you don't miss any upcoming video. And, if you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding. Thanks for watching, and happy coding.